Hello and welcome to section 6.3. Here are the answers for 6.2. You guys were working with some different properties of proportions. When you're doing those measuring problems, by the way, in the book, you may come up with a different answer if you use your Chromebook versus the book. So just kind of look at the process, see if your process was correct there. Because if you were zoomed in or out, you may have had a different picture, or the picture might have been a little distorted compared to what was in the book. I'm going to talk about similar polygons in section 6.3. So two polygons are going to be similar if they have corresponding angles being congruent and corresponding side lengths being proportional. And that's different than congruent polygons, because congruent polygons had corresponding angles being congruent and corresponding side lengths being congruent. So this is really this is very, very important. This one right here, the side lengths are going to be proportional. So in the diagram below, the two quadrilaterals are similar. You can write that they are similar using this little tilde, this little squiggly sign. It's kind of like the squiggly sign that's above a congruent symbol. And then notice the similarity statements. We have the corresponding vertices. So we have like F. So if we look at here, A and E match up. Okay, A and E match up. B and F match up. B and F match up. C and G. C and G. And D and H. So you can use the congruency state, or the similarity statements, just like we use the congruency statements. And then the ratios of the corresponding sides, again, you can use like AB to EF, AB to BF, and that's similar for all of them. So use this statement right here to your advantage, because it allows you to not even need a picture. Okay, so in the diagram it says that they're similar, so we're going to see that similarity symbol right there. List all pairs of congruent angles. So we just say, again, I don't even need that picture for this. R is congruent to X, S is congruent to Y, and I'm just looking at the statement above. I'm not even looking at the picture. And T is congruent to Z. Okay, check that the ratio of the corresponding side lengths are equal. So RS corresponds with XY, so 20 over 12, is that equal to, let's see, ST, and ST is right here, 30 over YZ, 18. So I'm using the similarity statement to write the ratios here. And then RT, so RT is 25, and XZ is 15. So I'm going to simplify all these. Divide by 4 here and get 5 over 3. Divide by 6 here and get 5 over 3. And then divide by 5 here and get 5 over 3. So yes, they all have the same simplified ratio. Write the ratios of the corresponding side lengths in a statement of proportionality. Okay, that you guys haven't seen here. All that is exactly what I did, but just without the numbers. Write the ratios of the corresponding side lengths in a statement of proportionality. So either this works here, or the book may do RS over XY equals ST over YZ, so just putting the actual side lengths rather than their numerical values, and then RT over XZ, and there you go. If two polygons are similar, then the ratio of the lengths of two corresponding sides is called their scale factor. We talked about their scale factor yesterday, and make sure when you're writing your scale factor, if they tell you a specific order, your scale factor has to go in that order. So RST to XYZ, and using this example, RST to XYZ, it's 5 to 3. If they said XYZ to RST, then it'd be 3 to 5. Okay, so using that information, determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. And again, here they're going to give you the specific example. Okay, so all the angles, angle angle, angle, and angle. All the angles are good to go. All right, we got the angles. Angles, check. All right, now they're side lengths, so I got to go 16 over 20, and then 20 over 25, and then 12 over 15, and 24 over 30. If I reduce all of those, I'm going to divide the first one by 4 and get 4 to 5. Divide the second one by 5 and get 4 to 5. Divide the third one by 3 and get 4 to 5. Divide the fourth one by 6 and get 4 to 5. So yep, that checks out. They are all the ratios reduced to the same value. And then it's saying the big one to the little one. So 5 to 4 or 5 to 4, not 4 to 5. This would be wrong. Okay? So make sure you read in the order that they want you to go, because that is significant. All right, it says find the value of x. It says that these two guys are similar. We're just going to set up a proportion and solve for x. 9 over 12, actually, yeah, we're going to go 9 to 12, and then we're going to go x to 20. There are tons and tons of different ways of doing this problem here. This is just one way. Okay, you could have done like 9 to x, and then you could do 12 to 20. All of these proportions are going to give you the same answer when you cross multiply. All right, compare the two perimeters. Do you notice anything? All right, well, let's see. These two things are supposed to be similar, by the way. In the book it says that they're similar. Let's compare the two perimeters. 20 plus 25 plus 30, and then 12 plus 15 plus 18. Here I'm going to get 45, and then here I'm going to get, let's see, 50, and then 75. Okay, so if I reduce 20 over 12, I could divide by 4 there, and that's going to give me 5/3. If I reduce by, I hope this works, reduce by 15 here, so divide by 15 on both of them, I get, let's see, 5/3. It works. Okay, good. Glad I didn't do my math wrong there. They both are the same. Okay, and that's significant. That works for all. Sorry about the bell. I'm gonna continue this video in a little bit. So if it doesn't make, hopefully, I'll put this picture here because I got students coming in now. There. Perimeters of similar polygons, they're gonna be the same. I'm gonna talk about this in just a little bit when I continue this video. Okay, let's see how much I can ramble here. Picking up making this video. So here's what I was saying. If you know that the two polygons are similar, the scale factor or their ratio of their perimeters is the same as the ratio of their side lengths. So let's say that these two polygons were similar, and you knew that this one was 3 and this one was 5. And you knew that this perimeter here was, say, 50. What you can do, you can figure out the perimeter of this one here really easily by using a proportion or rate. And you can do 3 to 5 equals 50 over the perimeter of the large object, and then cross multiply and solve for p. So it gives you a way to find the perimeter without knowing all of the side lengths. A town is building a new swimming pool. An Olympic pool is rectangular with length 50 by 25. I'm just going to draw this here. 50 by 25. The new pool will be similar shape but only 40 meters long. Okay, so 40 is not drawn to scale. Find the scale factor of the new pool to the Olympic pool. So it's similar. So the new pool is going to be 40 to 50 because it's the new pool to the Olympic pool. So that's 4 to 5. So that's going to be part A. Find the perimeter of an Olympic pool. You can either find the width here, or you could just say, well, I know that the perimeter is 50, 50, 45, 45. So that's 190. I'm going to move this picture here, get this out of the way. 190 is the Olympic pool. And then you could do this here. That would be one method of solving it. The other method is to find the width here using the scale factor and then add up all four sides. So either or will get you the right answer.